We are going to start again. Okay. So we are going to discuss the linearly dependence and the linearly independence of the vectors. Suppose let V be a vector space over the field F. Right? Let a collection of vectors of V, say V1, V2, and Vn, right? They are said to be linearly dependent first. Linearly dependent over F. Okay. Or simply we can say that dependent if there exists scalars, right? A1, A2, An from the field F, and not all of them 0, such that A1 V1 plus A2 V2 plus An Vn is equal to 0. Okay.
Yeah.
That means the set of vectors is said to be linearly dependent if this linear combination has only one solution, that is A1, A2, A3 all are equal to not all are equal to 0. At least there exists one A1 or A2 or AK, at least one, which is not equal to 0, and this is again the linear combination is again 0. Then we can say that the set of vectors are linearly dependent. Otherwise they are linearly independent. So we can take an example. Suppose we have a set of vectors that is 2, 0 and 0, 3. Okay. Now what we are going to do, we are just going to examine that either they are linearly independent or linearly dependent. So for that, what we are going to do, suppose we'll have to take, there are 2 vectors in the collection, so we'll have to take at least 2 scalars, say k1 and k2 from the field F. Right? So we can write the linear combination with the scalars and the vectors like this: 2, 0 plus k2 times 0, 3, and this is equal to 0, 0. 0 is a 0 vector, right? So we can write 2 times k1, 0 plus 0 times 3 k2 is equal to 0, 0. Now we can add up the vectors on the left hand side. That is 2 times k1 plus 0 and 0 plus 3 times k2 is equal to 0, 0. And these 2 vectors are equal. So the corresponding entries should be equal. That means 2k1 is equal to 0 and 3k2 is equal to 0. This implies k1 is equal to 0 and k2 is equal to 0. So we can say that the vectors are linearly independent. So the vectors are linearly independent. Now suppose we have another example. We have a vector that is 1, 2 and then 4, 8. Okay. Now the same question is same. We are going to check the independence or the dependence of the set of vectors. So in this question we can say that this vector is this vector is just 4 times of this vector. That means if we multiply 4 into 2 comma 2 and plus is equal to the 4 comma 8, that is the second vector. They are dependent. The relation is that 4 times 1 comma 2 minus 4 times 8 comma 0 is equal to 0. So we can write this combination like this: 4 times 1 comma 2 and plus minus 1 times 4 comma 8 is equal to 0 comma 0. It should be 0 comma 0. So the relation is that where k1 is equal to 4 and k2 is equal to minus 1 and both are not equal to 0, and either they are equal to 0. The linear combination is again 0, but not k1 is equal to 0 and k2 is equal to 0. Both are non-zero, and even the linear combination is 0. That means the vectors are linearly dependent, right?
Got it. Yeah. Because it's just a factor of 4. So you don't even have to solve it the other way.
Right. Because it is very simple to see that this vector is a 4 times of the first vector. So we have the relation. So that means they are dependent, not independent.
Got it.
This is the way. So we can, by this method, we can check either they are independent or dependent. Okay, is it clear?
Yeah.
Any doubt? Any doubt?
No.
So I think it is sufficient for the end.
Okay.
Thank you very much for your time.
Thank you, Nadeem.
And how was the essay? Ada sent you the essay.
Yeah, I just needed help like correcting it. Like I had it, I wrote it, but there were just some like, I guess it just needed editing over it to make it a little better. So she helped a lot with that.
And it is your last year of your course?
Yeah, I actually just have 1 month left actually.
Okay. And there is no paper of mathematical paper?
All done.
Okay. That means it is our last meeting, right?
Yeah.
Okay, thank you.
I'm all done.
Take care. Bye-bye.
Thank you. Bye.